this part here, what we need to do is explain why the curve has only one stationary value. You just dy dx, you don't worry about it first. Even in exam, you don't know what to do, right? You just want to show that dy dx equals to 0 as one solution. So this case here, you just dy dx first. 3ax plus 1 square. Okay, as stationary value. We know that dy dx is equal to 0. This will be a over a. So okay, that's it. So for part B, explain the stationary value at the point of inflection when a is equals to 3 lah. So you just want to find, I think d square y dx square equals to 0. Then you win already. So this case here, you just second derivative this out. Ooh. Okay, this will be when a goes to 3. X equals to minus 1 over 3. So d square y dx square. Hence, stationary point of inflection. Okay, point of inflection got two kind, guys. Hence, you can conclude. So this. Okay, I'll show you how do you see. Okay, this is a point of inflection. Okay, this is a point of inflection. Okay, this is point of inflection. Point of inflection is like a S curve, right? It's essentially the part where the concavity changes. So let me explain to you what does it mean. It means that when this is moving this side, that is the point where it changes the curvature, the concavity. Stationary point of inflection has an added layer. So which is to say that this here, this dy dx here is 0. So this point here, dy dx is more than 0. This one dy dx is a negative value. It's not 0, okay? So when it's 0, right, it's like what do you call it? This is also n. Square y dx square equals 0. And dy dx equals to 0. Okay. So these are two very important concepts. So you can only conclude that stationary point inflection when both of these are thick. That's the idea. But this is just a point of inflection, just a typical point of inflection. Then this is stationary point inflection. Yes, yes, you can.